Okay, so welcome back, and now we're going to talk about Archimedes spirals. So Archimedes spirals is based on just really one thing, theta. So, and theta has to be less than or, equal, or greater than or equal to 0. So what this means is, as theta increases, so does the radius. And so we get this everlasting spiral where it just keeps going and going and going without bound. So it just keeps going. So as theta increases, the spiral keeps getting wider and wider, and it keeps going around and around in circles like the snail, right? So there's really no maximum in this one, unless you're dealing with a restricted interval. There's no really apparent symmetry, really, to this curve. Even though it feels like there's symmetry there, there's really no symmetry. So really, it's just about plotting points. And that's really all it is over an interval, and then you plot it. So let's do an example, and I'll show you what we mean. So in this example, we'll just plot the theta over 2 pi. Okay, so we'll just plot this over 0 to 2 pi. Okay, so basically if we have a table, right, so theta and r, okay, so basically it just says when theta is 0, r is 0, and when you're at pi over 6, this is pi over 6, and when this is pi over 4, this is pi over 4, and when this is pi over 3, this is pi over 3, right, so then we get pi over 2, right? That's right. We get 2 pi over 3, and we get 3 pi over 4, and we get 5 pi over 6. And we get the same thing over on this side, right? Okay. And so if we take our calculator and we plot these, so let's see, so if we look at pi over 4 is 0.78, 0.785. So 0.785, let's say, is right about maybe there. Okay. And 1.57, pi over 2 is 1.57. So let's say it's right about there. And at pi, it's 3.14. So that's going to be, well, that's going to be out here. Is that right? You just double check. Yeah, 3.14. So So let's say that's about right there. And then at 3 pi over 2, that's 4.7. So 3 pi over 2, that's going to be 4.7. So that's going to be way down here, right? So it looks like I didn't make my graph big enough. Oops, hold on. Oh, that's why. Hold on a second. Oh, yeah. Hold on. I didn't scale mine correctly. That's why I wasn't looking right. Okay, so let's redo this. Okay. Yeah, I was going to say now. Okay, 1, 3, 1, 3, 1, 3. Okay. Now this should be better. Okay, so 0, 0, right? So we got 0, 0. And then at 30 degrees, so at 30 degrees, so that's, well, let's do this. Let's just do it. Each one. So I don't have my calculator. Where did I put my calculator? Oh, so let's do this. I'm just going to use my calculator here. Okay, so we got 0, 0, and I'm just going to plot these points. Okay, so pi over 6, so that's 3.14. 0.52. So at 30 degrees, it's 0.52. So that's going to be right about, let's say, here. And then pi over 4. .785. So that's going to be, let's say, right about here. And then pi over 3. .05. So pi over 3 is going to be 60. So let's say that's going to be 1.05. Let's say we're right about there. And then at pi over 2, right? .57. Oh, that should be probably here. Okay. And then 2 pi over 3. .09. So what's going to happen here? Let's go to pi. So pi is going to be 3.14. So it's going to be about right there. So 0.52, so 0, 0.52, and then 0.79. And then 1.05. Okay. And then at, what were some of the others? And then 4.71. So 4.71 is right about here. .5. So 5.5 is, let's say, way out here. Oops. Let's say, but right about here, let's say. So now, if we just connect this, right, it's going to look something like this. It's going to go out. Like that. So again, the main thing is when it comes to spirals, you just have to plot points. And again, you don't have to plot as many points or do the table as many points as I did. If you want to just do here and maybe a couple points here, and just do the quadrantal angles, you could do that. Or if you want to do the 45-degree angles, you could do that. But again, it's in this case, the way you're going to graph this is just by point plotting. Have a great day.